Saurabh Bagrecha, and I'm a senior developer advocate at MongoDB. Part of my role is to speak at events like this and engage into community and get our users excited about our product. So I'm gonna just do that today. I'm gonna get you excited on Atlas vector search, and hopefully I'll be successful in that. But before that, I wanna know if anybody here knows which is the biggest bank in India, which is the biggest private bank in India, HDFC, right? So if HDFC is investing into something, they might be thinking about the future, all right? Maybe 5 years, 10 years, or maybe the next decade. So what they are doing with vector search, with LLMs, this was the article published by, just a second. All right, so this is an article published in the Economic Times that the big banks are taking a deep look into LLMs. What are they? Why it's profitable to invest into such things? Does it even make sense to try just new trendy technology, or is it just a hype? Right? Let's see. So, does anybody know the full form of LLM here? Large language models, right? So the language is the key, right? So we'll keep that in mind, that large language model understand language, right? And that would be the base of the complete thing that we are going to talk about today. So the biggest in the lending business are investing too much. They want to figure out the ways and tactics to use LLMs and to make their customers happy, to make their operations efficient. They are doing anything and almost everything that can be possible with LLMs. And I'm not making up stuff, right? We are going to take a look at some use cases, some already existing apps that you might be using right now, right? That are already using LLMs in their daily lives. So before we talk about LLM, before we talk about vector search, before we even touch Atlas vector search, do you ever find yourself asking any of these questions where you are not just sure about the thing you are looking for? You have some idea, but you are not exactly sure about that, right? Maybe you are looking for a bedside lamp because you are renovating your home, right? But you might not know what to call it. Is it a bedside lamp, or it's a light used in the bedroom? So you just want to have that capability where the machine understands your priority, or maybe your ask, without even explaining or mentioning the exact same thing, right? So you might, here and there, you might find yourself doing these things. So let's take a look at few use cases that have been, enabled by LLMs and Gen AI and the other machine learning things that are there. But we'll be mostly focusing on generative AI, how it helps, right? So if it's a support chat use case, I don't have to talk about it, right? That's the first and biggest use case of Gen AI. If it's for maintenance, right? So there's a startup that used audio files generated through an engine. They vectorized it. We'll see how that happens and how that helps you in building apps, and especially with MongoDB, how easy it is to do that. They vectorized the sound, that like when you start the machine, right? How it's working. So the machines or the engines that are having the same defect would output the same kind of sound, right? So you can analyze what kind of trouble it is it's having, right? Maybe it's a spark plug issue. Maybe you haven't changed the oil. Maybe your clutch plates are damaged, or what. So they used all the audio files. So the next time a new car comes in, they record the voice, they search for something similar, and if they find the similar known issues that they have in their knowledge bank, which is, of course, they might be using MongoDB because they want to make their developers productive, they can do that with Gen AI. What is similarity search, right? maybe you are showing iPhones, maybe you are Amazon, maybe you are showing iPhones. The next thing to do, or the next product to suggest them, might not be a Redmi phone or a Samsung Galaxy S24. It might make sense to show them mobile covers for iPhone, right? Because they've already mentioned their interest in iPhone, they have purchased it. The next thing you should suggest them is maybe mobile covers, maybe MagSafe chargers, or maybe MagSafe wallet, right? So doing those kinds of stuff and making your apps intelligent is possible by generative AI. So finding the right resource, it is what is similarity search. Another one, research, right? So gone are the days when you had to mug up all the research paper and then like find solutions to your problem. Just feed all the research paper to a LLM or maybe a Gen AI model and then ask them very ambiguous questions, and they'll give you the right answers most of the time. Image search. We're going to see a live demo of this, how image search is possible. And I'm really confident on the results because the result that it gave me made me really happy. All right, so what is vector search? Let's keep all the fluff out and let's now focus on the technical side of things, right? What is vector search? Anybody would like to take a guess? Maybe 5, 10 words, sentence. What is vector search? Anybody? Anybody has ever heard about it? All right, a few folks have heard about it. But before that, let's learn about what is vector, because once we understand the vector and how they are presented, how they are stored, it's very easy to understand what is vector search, and then we'll connect it to an app and make it intelligent right out of the box. So vector is a coordinate. That's it. Vector is a coordinate. So if you have distance and time graph, you get speed, right? So you at any point of time, you can figure out what was the speed of the vehicle. If you have speed versus time graph, it would be acceleration. So that's intelligence, right? That makes you understand or maybe analyze some situation because you have 2 coordinates. Now let's take an example of 3 coordinates, right? It's your 3D games. They detect the position where the missile has been launched and at what velocity is moving, right? You mentioned gravity and all the physics stuff to make that game look real world. Now let's take another dimension. 3 dimension is already sphere, right? Now take another dimension, 4. How about having 1536 dimensions? Like I don't know what that space would look like. But having just 3 dimensions was making our apps intelligent to a stage. How about having 1536 dimensions? Would that make our apps more intelligent? The answer is yes. That's what ChatGPT is using, right? They have more than thousands of coordinates for every single word or sentence. So when 2 sentences are similar, we are going to see what happens in the vector space. But this is not just limited to text. This can be easily replicated to other file formats, right? Images, and even audio, right? How do you do that? You use a LLM, or maybe let's take a look at those technical details later on. But just know that every data file, or let's say text, audio, maybe even videos now, can be vectorized and can be have these coordinates. So these are 1536 coordinates. So this sentence would live in a vector space and would have this address. So this is basically address or coordinate, whatever you want to call it, right? Now, you pass the data to an encoder and you get a vector. As simple as that. So you pass a string, you pass an image, you get coordinates, right? Similar vectors plotted in space will be near one another. What are similar vectors, right? Maybe a dog and cat are similar because they are animals, but they are different because they are dog and cat, right? So we'll plot them, right? Based on the text we get, based on the image we get, we'll plot them. And if a man is plotted here, woman would be nearer because they both are human. But they are far apart because their gender is different. And this is exactly where large language model shines, because they have been trained on billions of parameters and things like that, and maybe, I don't know if it has gone to trillions of magnitude, but they have been trained to understand language, right? So if you provide an image, they kind of try to understand the sentiment of that image. Maybe is it a horse in the image? Okay, we'll understand it, we'll vectorize it, we'll store it. And if the next image comes in and it's a dog, it again vectorizes it and keeps it nearer to the horse because they both are semantically similar, right? So this is what's happening, very simple. It understands the language, it gets vectorized, and because they are similar, they kept nearer. If they don't have any similarity, they'll be very far away. All right. Don't ask me why man and woman are so closer and king and queen are so far, and like king is more far to man than woman. I don't know. It's just a 2D representation of it. So no offense to anyone, but this is a 2D representation of a 1536 dimension thing, or maybe just a random guess. I guess it's a random guess. Not just images, we just talked about, right? Text, videos, anything. So if it's a multi-model trained large language model, you would have some sort of this, right? Where you would vectorize images and text and all those things. Now let's use vectors. So similar things kept nearer, non-similar things don't have any relation, right? So there are some specific formulas that you would use for different kind of data types, right? So for Euclidean, it's as simple as any mathematical formula that you might have learned in elementary school, which is x2 square minus x1 square plus y2 square minus y1 square, and then getting under root of that. You get some distance, right? Now imagine that for 1536 dimension, z2 square, y2 square, x2 square, and then a2 square, and then uske baad jo bhi hota hai. So that's the beauty of it, right? You are just using math, and you are sounding intelligent in front of your customers. That's as simple as that. Maybe plugging in an API or whatever. We'll make our apps intelligent by the end of this presentation. So stay tuned with me and ask any question if you get anything. Just feel free to raise your hands in between the session. It's completely fine, because we want to make our foundation strong to understand the not so difficult but difficult stuff. All right, so Euclidean is that mathematical formula. Cosine is a different formula that I don't remember. And then dot product is something else. Why would you use Euclidean? So they all have their own specific use case. So if it's an image, you would use Euclidean. If it's a text or similar concepts, or maybe the research paper thing that we were just talking about, maybe use cosine, right? Dot product, I don't know where would you use it, but that has a different use case for it. All right. Now let's talk about Atlas Vector Search, because MongoDB paid me to travel here, stay here, and then come up. I have to talk about Atlas Vector Search. So the next part of the presentation, which would be the half part of it, we'll be just talking about Atlas Vector Search, Amazon Bedrock, because it's an Amazon hosted event, and how to make your apps intelligent. What is Atlas Vector Search? Does anybody know what's a vector search database? So we just learned vector search. The database that stores vectors is called a vector search database, right? But MongoDB is not just a vector search database. It's much more than that, right? We provide vector search capabilities out of the box because of our foundationally fundamental document model, right? It's so easy for us to add any new features because it maps organically to your objects in the code, to your classes in your code, to your programming constructs, just the way you would, you know, model your app in your, model your application in your code. You just store those documents directly into the database. No normalization, no 1NF, no 2NF, no 3NF, and no BCNF, right? You would just store them the way you want to access them. And you would even do some sort of denormalization when needed, right? Because you don't want to spend time on adding a new caching layer on top of your operational database just to make your queries faster. Why don't you model your data to be faster in itself? We can talk about these technical details in our booth, which is just in front of this gate, the MongoDB booth. And we would love to answer any of your questions, not just AI, not just vector search, anything related to application development and anything related to document model. All right, so we would get our data, we would pass it to encoder, we would get some vectors, we would store it in a vector search database. That you would be doing with any vector search database, and that's the same thing you would be doing with MongoDB as well. All right, and the next time, there's a read flow as well. So the next time you are feeding in the new engine sound, you'd search for those vectors in your database, and it would give you similar results. Okay, this kind of voice is usually be the cause of faulty Spark plug, right? All right, so how would you do that? This is a typical document in MongoDB, right? Any application that you would build, you would have some keys and some values and some nested documents, some arrays and embedded information into it, right? So as I mentioned, we are a product. We are a solution to make your developers productive, right? We want to make you love your developers, right? We don't want to force you to be in a constructed or maybe confined environment where you are not allowed to innovate, because the next thing you want to change into your table is going to cause downtime. So your developers are a bit reluctant before doing that, right? We want to have a database that's so agile that it doesn't cost you any innovation tax, right? So you have your already existing documents. You'd pass it to a LLM, and you'd get a vector, right? So let's talk about movies, right? You would get some text about that movie, some description. You'd pass that, you'd get some vector, you'd store it in the document. And that's the same thing you would do for any kind of application. You'd just pass your data, and once you get the vector embedding, so these all coordinates are embeddings. Whenever I mention embeddings and vectors, they are interchangeably the same thing, if I'm not wrong. So that's it. You would store that. You'd create an index on that field so that you can search on it later on, which is a vector search index. I'm using a KNN vector type. And as I mentioned, 1536 dimensions. The more the dimensions, the more intelligent it is, or maybe arguably not. So you have to keep that threshold in mind. Too many dimensions can cause it to not result into anything, and too less dimension can cause it to give not so quality-oriented results, right? And then you would explain a formula that you would want to use for similarity search. So that's it. This is how a query would look like. The same database. You are not using any different database, right? So you have already built an app on MongoDB. It's running into production. The only thing that you have to do is, okay, the timer has started. I only have 7 minutes and 30 seconds. Let's keep this going, all right? So the only thing that you are going to add into your application is this query, and you can perform vector search. What do you have to change in MongoDB? Just go to Atlas, add a new index, which is vector search index, and start searching. All right, let's see how do we do it with AWS services, right? This is AWS Lambda. I hope most of you must have used it already. But how many of you have used any model of Amazon Bedrock? Anyone here ever used Amazon Bedrock? No one? You are missing out on a lot. Maybe just one person. So Amazon Bedrock, what it provides, let's see it on the next slide, but let's just look at the simple write flow. You are a user, you create some record in your application, maybe a voice of engine or something that gets stored into the MongoDB database. You trigger a new, you trigger a new function. Hey, I've got a new document. Let's vectorize it and let's store those vectors into the same document. And that's it. That's the write flow. How do you get those vectors? You pass this document to Amazon Bedrock, any of their models, and you get vector embeddings. It's as simple as that. We're going to take a look at the code as well. In the read flow, whenever a user asks for something that they think they are asking for something similar, you'd search for that query. You again vectorize that query. Okay, so I'm asking, hey, this is the new engine sound. So you take the new engine sound, you vectorize it and search for it in the database, and you get similar results. That was the read flow, and that are the only two things you have to worry about when you have to build any Gen AI application. All right, so this is retrieval augmented generation, a little bit complex, but think of it why it is different from vector search. So vector search give you similar results or similarly related documents, but retrieval augmented generation adds a layer on top of it and gives you a chat-like interface. So instead of giving you the related documents, which you can have business logic in your application and just revert it back to the user, you can have a conversational API. That is RAG in short. All right, so what is Amazon Bedrock, right? Because we want to discuss, we have already discussed vector search, and there was a missing piece, the LLM model, the encoder. So this is nothing else but that encoder, right? They have different startups. AWS has invested a lot of money in Anthropic recently, right? So they've acquired those models. And now you can just, in a few clicks, you can have your that model set up. You can get those APIs, use your secret key and access ID, and just start searching. So what they are used for, you pass your documents to them, they give you the vector, and the next time a query comes in, you pass that query to them, and they give you a vector, and you search for all those related vectors in your database. And MongoDB helps you do that seamlessly, easily. So this is a demo that we created using Amazon Bedrock and Atlas Vector Search. So you feed any image of yours. You can search for Hugging Face MongoDB celeb matcher on Google, and you'd get this demo. Just take a selfie of yours. I've taken mine. And if it has given that Elon Musk looks like me, so I was pretty impressed by that. And I think it's working, right? So that's a great use case, right? Maybe tell me a name of a director of any movie. Christopher Nolan, right? Maybe he's looking for, maybe some of his celebrity is asking too much money. Maybe he wants to find someone similar that looks like him. So they'll feed that image. They'll get all the related celebrities, and he'll just kick out the previous one and ask the new one to be on roll, right? It's not that easy, I know, but it happens. So this is the code, but don't look at the code. Just look at these three highlighted pieces that I'm going to show. First thing, you're going to get the embeddings for that uploaded image. What was the uploaded image? That one. And you have all the celebrity data in your database already. Maybe 2,000 celebrities. You take the number, all right? So the next time I'm searching for the image, so you already have the database of celebrity images, their vectors. The next time you are searching for an image, you get this line of code. I don't know how visible is the text. You get the vector for that. You search for that vector in your database, and you return the results to the user. Some business logic, you want to show the image or text. So if you see, there was some text behind that as well. Why it showed this celebrity, right? So this says the first image shows a person riding a donkey or small horse. It was a horse, by the way. I don't know why it's recognizing it as donkey. Wearing sunglasses and a t-shirt. So it analyzed it using that, right? So it also provides images, it's the description and things like that. And Kushagra was saying like my colleague, this says a donkey riding a small horse, and I don't know what he meant by that. So that's it. That's all you had to do with that. Just take your image, vectorize it, you get the results, right? If that's not magic to you, tell me what it is. What is magic to you, right? This is magic. And by just using maths, you are doing magic. And you can act as smart in front of your customers, and they would never guess, how did you do that? Scan this QR code, build your own app. It has the RAG example as well as the similarity vector search.